Welcome to this next lecture in module number 4 on ETL systems. So today I'm going to talk about ETL subsystems. And again, the source use for this lecture is the book on by Kimball on ETL toolkit. So there are 34 subsystems of ETL, and they are basically divided into 4 categories. So first three are related to extracting process, and second three is what we call as the transformation. So it is also called as the cleaning and conforming data steps. So 4 to 8, and then data needs to be prepared for presentation. So there are modules from 9 to 21, so that makes it 13 modules which are there, and rest of the modules are for managing the ETL environment. So the subsystems 22 to 34 are related to that. So what I've done is I have broken up the lectures into 2 parts. So right now I'm going to talk about extracting and cleaning and conforming. So these 2 topics I'm going to cover today, and the next remaining modules will be covered in another lecture. And then the last lecture in this module would be on the ETL steps. So that would be another like half an hour or so. So let me begin with the subsystems. So so there are 3 subsystems that are there for extraction, for the extracting process, and these are so first one is data profiling. So let me just quickly give you some idea about this data profiling. Let me close this video because some text is getting hidden under this. So data profiling, it's basically a technical analysis of the data to describe its content, consistency and structure. And it is like whenever you do the select distinct query in SQL, right? So you are like doing a kind of investigation, like how many distinct values we have for a particular column, right? So we do a lot of profiling of the data, similar profiling of the data under this subsystem, and this subsystem is responsible for doing the data profiling. And tools are preferred over rolling out your own system for this, okay, or you're rolling out your own kind of a solution for this. So it is just like you want to do some initial analysis on the data. So you do that using data profiling. The second subsystem is about change data capture systems. That is, we call it the CDC system. So what happens here is that there are some very large data warehouses which cannot be refreshed during every ETL cycle. So there must be a capability to transfer only the relevant changes to source data since the last update. So when you last updated your data warehouse, from then onwards, so there would be some changes that are made. So we only keep track of those changes and update only those changes in the next refresh cycle, because you can't do a complete refresh of the data warehouse because of the size of the data warehouse and the window that is available to you to do this, the ETL window that is available from the source systems. So isolating the latest source data is called change data capture. Okay. And the third is the actual extract systems. That is the third subsystem of the extracting process. So all source data need not be on a single machine. So that is very important for us to understand that the data that you need for the data warehouse will reside on multiple systems. So capability to extract data, so you must have a solution for that, so that you should be able to connect to these different machines and extract the data. Then the type of data, right? So heterogeneous nature of the data. So capability to extract data from multiple sources like RDBMSs, flat files, XML sources, weblogs, complex ERP systems. So all these are are different kinds of source systems for you, and they pose different kinds of challenges for you. Then we have mainframes and legacy systems, which throw another set of challenges for you. So the best solution in these cases is that you request the owner of the source system to extract data for you in a flat file format and just hand it over to you. And then we also talk about stream extracts versus extracts to file. So as we move from, we talked in the previous lecture, we talked about latency. So what are the latency requirements, right? So if the latency requirements are not very strict, that is, you are comfortable with some form of latency, then extract to file is definitely a better option. But if the latency requirements are like that of a real-time system, then stream extracts are preferred. But in general, we prefer extracts to file, because then you can actually see each and every step that is happening to the data, or any kind of transformation that happens. And then also, to handle large volumes of data, we need to talk about data compression and encryption. And encryption is very important from a security point of view, because when you are extracting data from on a public network, then encryption is highly recommended. And again, compression, as you know, is recommended, because if you are dealing with large volumes of data, so you first compress it and then send it over the network, so that you save bandwidth. Then let me come to the second aspect of subsystems. That is subsystems 4 to 8, and they mainly refer to cleaning and conforming data. So the fourth subsystem is about data cleansing. So it's a data cleansing system. So these are like, there are slightly conflicting requirements here. So I'll talk about that. So for the main purpose of this is that fix dirty data. Like in the first lecture in the module on ETL, I talked about quality of data, and if you put in garbage, you'll get garbage out, right? So garbage in, garbage out kind of scenario. So you need to fix dirty data, yet at the same time, the data warehouse is expected to provide an accurate picture of data as captured by the production systems. So, but if there is a error, right, or if there is a sensor which malfunctioned and reported a wrong value, it has to be corrected, because if you don't correct it, your analysis will all go wrong, right? So both aspects are important. So proper balance between conflicting goals, the above two conflicting goals, is very, very critical. And this module is basically responsible for data quality. And there's a very nice book on data quality by Jack Oslin. So it is called the Accuracy Dimension, and it was published in 2002. So it is a strongly recommended book for those who have special interest in data quality. So he proposed this concept of quality screens, right? And there are three kinds of screens that are used, that are defined. So first ones are the column screens, and if you know, what these column screens do is they check for format, column and null constraints. So column constraints, you understand, like suppose I have a say CGPA column, so I know that the CGPA cannot be less than 0, right, and greater than 10. So I can put this constraint on the CGPA column. And then there are null and not null constraints. So all those things are checked by the column screens, and any violation is reported. So that's the first kind of check. This is the most simple kind of check that is done using quality screens. Then the next set are the structure screens. So it basically checks hierarchies, relationships among columns like primary key, foreign key between two tables. And we also check like blocks of columns which are nothing but which comprise the address field, so to check whether the addresses are correct or not. And then the third form of screens are the business rule screens, and these are like complex tests that you do on the data, and which is not possible using column and structure screens. Say for example, so there's an example here, customer profile. Say suppose an airlines company is doing a customer profiling, and he wants to so there is a customer who wants a lifetime platinum frequent flyer. So you need to check whether this customer has been a member for at least 5 years of the scheme, at least a member of the scheme for 5 years, and has flown more than 2 million miles. So these kind of checks are done or performed using the business rule screens. So these screens, we call them quality screens, and they play a very, very important role in cleaning the data. And then we have the next subsystem called as the error event scheme. So error event schema, in fact it's a kind of a dimensional schema. So I'll give you the dimensional schema in the next slide. So it's a centralized dimensional schema to record every error thrown by a quality screen anywhere in the ETL pipeline. So we talked about these quality screens in the previous slide, or in the previous subsystem. So it is an extension of that, and it tries to record every error. So error event fact table is there, and with a single column primary key, which is the surrogate key for this. And it is an unusual thing to have a single column primary key, but it has there are reasons for this. And it has date, batch, and screen dimensions. So there are 3 dimensions that apply. And the granularity of this particular fact table is that any screen event that is generated is captured. And then we have another fact table which we call as the error event detail fact table at a lower grain, where every field in each error event is recorded. So let me show you the screenshot of this. So this is the you can see this is the error event fact table, and this is the error event detail fact table. So you can see that there is a date dimension. So there is an error here in the screenshot. So this should be date. There is a batch dimension for which batch you are doing the processing, and there is a screen dimension. So here it could be, the screens could be like the column screens, the business rule scheme, right? Or screen, sorry. And there is another one, I forgot the name, that was structure screen, right? And then there could be a structure screen. So these are the 3 types of screens here. And then you can see here there's a batch key, and then there is this is a primary key, and then these are the 3 composite keys, foreign keys that are available. And it talks about time of day and the severity score, and the grain, as you see, is the screen event, any event that is generated by the that is flagged by the screen. And then you have the key. So this error event key actually say it refers to this, right? So, and then there is a table key, in which table this error is occurring, then the record identifier, field identifier, and the error condition. So if this happened in a particular table, so I record everything about that table, the table name, so which is a foreign key, right? Then there is a record identifier, so which record I'm talking about, and in that record which field I'm talking about, right? And then I talk about the error condition. So this is the error event schema. It's just like a dimensional schema with slight deviations. So it allows you to analyze the errors at a later point of time. And then we have the audit. The 6th subsystem is about the audit dimension assembler. Let me clear the annotations here, right? And it's a special dimension table that is assembled in the back room for each fact table that you have. So it's you can say that this audit dimension, which you don't see as part of the dimensional schema, because this is not there for the end users. It is only for the backroom people to, or the ETL team to look at. So it is not visible. But it is kind of a metadata that is elevated to real data. And say, for example, shipments fact table is updated once per day from a batch file. And assume that there are no errors flagged. So there will be only one audit dimension row would be attached to every fact table row loaded today. So it will say that there is no error. So there will be an audit dimension record with saying that no error, everything is fine. So it will be attached to that. And if you had some fact rows which where there was some kind of error, like discount dollar is out of bound, right? Then one more audit dimension row will be needed to flag this condition. So we'll add a dimension row in the audit dimension to map this condition. And this is how it typically looks like. So you can see here very clearly that this is the shipment fact and this is the audit dimension, right? So this is the new thing that we are talking about. Others are the general dimensions that apply here, and then there are some other. So these are the facts, right? And so one record for each shipment line item. So the grain is that every item that is shipped will get recorded into this fact table. That is a normal situation. And here is the overall, here is the audit dimension. So it is the overall quality, completeness. So we talk about lots of things here. And we also talk about, so this is a screens failed. So here we talk about which all screens failed during this particular audit, right? And one record for each distinct audit condition. So and one of them is no error, right? So that should be the default condition, but unfortunately that does not happen, and there are lots of errors that are flagged by these screens, and then they are recorded here. So this is the audit dimension. And then then let me come to the seventh system in the seventh subsystem, and this is a deduplication system. So let me clear this annotation. I always forget to do that. So basically, I'll give you an example to explain this. So there may be many customer dimensions or customer master tables in different sources, and there may be common customers in these systems, right? So customer information may need to be merged from several lines of business. So this is very important, right? Several lines of business. So identical values. So when we try to compare these customers, so you find that there are identical values in some key columns, right? Other columns might contradict the match in key columns. So there may be other columns which say, I feel that these two customers are the same and their names are matching, their addresses are matching, but maybe the gender is not matching, right? So something happens there. So no universal column that makes the merge or the deduplication easy. So it becomes a very difficult problem. So you think about this, that how do you deduplicate a set of, I think I mentioned this in the previous lecture also, how do you deduplicate among 1 million customers, right? So I say maybe 20 of them are having duplicate records in the database. So how do you check that? If you find exact match between two customer rows records, then it is perfectly fine. But if, say, out of 50 attributes that I'm capturing, 48 are matching but 2 are not matching, so what kind of decision would you take in this? So we generally use what are called as fuzzy approaches, nearly matching names and addresses. That's what we try to do. And then we have another concept of what is called as survivorship, and it's a process of combining a set of matched records into a unified image that combines the highest quality columns for matched records into a conformed row. So I merged these two into a conformed row, and highly matched columns, highest quality columns from the matched records are used for building this new conformed row. So this is the deduplication system, and as I said earlier also, it looks very innocuous, right? But it is a very complex system. So you can think of developing deduplication algorithms for customers, for products, and anything similar, any other entity. And then we finally have the eighth subsystem, and this is called as the conforming subsystem. And here what we do is we try to conform the dimensions and facts, right? So when I say dimensions, so it also talks about the previous, it also takes into account the previous deduplication thing that I was talking about. And you can see here the same dimensions apply to many fact tables. So conforming dimensions is required when the same dimension is kind of applying to different dimensions, okay? So different facts. So conformed dimensions can be defined in 3 different ways. Like if you have exact replicas of 2 dimensions, then they are conformed. If I use a subset of records from one dimension and attach it to another fact table, then again they are called as conformed. And also if I take a subset of columns from the dimension and attach it to another fact table, then they are also called as conformed dimensions. So this system defines or conforms the dimensions. Another important aspect is that you want to conform the facts. So same fact appearing in different fact tables. So this is often required, and there's a kind of analysis that we want to do on this that is called as drill across, where you want to work on conformed facts on the same fact attached to different star schemas and probably to different dimensions, right? So you want to do this analysis called as drill across. Typically what we do is we do a kind of analysis which requires one star schema, right? So many times we may want to do analysis that requires the same fact that appears in multiple star schemas, right? So this is the cleaning and conforming subsystem. And for this, one minute, you need to refer to this figure 19.3 of T2. So it is quite an involved thing, and I could not get access to this table, soft copy. So what I'll do is I'll take a picture of that and attach it onto the slides if I don't get a soft version of this figure. Otherwise I'll draw it if nothing else works, right? So I'll add this thing into the lecture slides before it reaches you. So next things are the remaining subsystems from number 9 to number 34. And that will be covered in the lecture 3 of the not lecture 3, but it's an extension of lecture 2, and the last lecture in this module will be on the ETL steps. So that would be lecture number 3. Okay, so this is actually lecture 2 extended, and this will be lecture number 3. So I'll talk about the remaining subsystems. Probably it will take me an hour to do that. And then I'll be talking about ETL steps, which I presume would take me another half an hour. So ETL is a long topic, and but the most things you learn about ETL come from actual practice and not just from theory, right? But it helps you to understand the basics, the basic concepts in ETL and the basic processes involved in the ETL process. So thank you.